In this video, we're going to take a look at solving quadratics by factoring. I provided a blank copy of the worksheet if you want to follow along. Otherwise, you can just watch the video. All right, first thing of all, we want to make sure we understand what is meant by the word solve. Solving means to find the value or values that allow an equation to be true. And so we need an equation, we need a variable, and we have to know what the equation equals. So then we can work through a process to find the value or values of the variable. Because we're working with quadratics, there will be more than one value because that represents the roots on our graph. And let's get right into it. So we're also told we need to solve by factoring. Factoring means we're finding things that multiply together to give the desired result. So if we're factoring a quadratic expression, we're finding two factors, usually two sets of brackets that multiply together to give the desired quadratic equation. Anytime we're factoring, or anytime we're asked to solve, we're going to start by factoring, and we're going to start with greatest common factor. So we're going to start by looking at 3x squared minus 12 equals 0. I'm going to look at all the terms on the left side of the equation and see is there any number I can divide out of 3 and negative 12? And the answer is 3. That is the greatest common factor they have. So I'm going to write that in the beginning. And then inside the brackets, what I'm going to do is divide each of these terms by 3. And that's what's going to go in the brackets. So we're going to end up with 3 times x squared minus 4. So far, so good. We have not fully factored though. Hopefully you notice in the brackets we have a difference of squares, and so we can factor this some more. And so we're going to end up with this equals 0, and we're going to end up with x plus 2, x minus 2 equals 0. Now that we have all the factors, we can start to set this whole thing equal to 0. I think it's called the zero product property, tells us that if an equation is equal to 0, one of the factors in the equation must equal 0. So if I want this whole thing to equal 0, I must be multiplying by 0 somewhere in the equation. I can't turn the 3 into a 0, but I can set this factor equal to 0, and or I can set this factor equal to 0. And that's what we're going to do next. So I'm just going to move this over so I have more room to write, and then we'll do that. So the whole thing will go to 0 if this factor is equal to 0. Let's find which x value allows that to happen. So I write a separate equation setting that factor equal to 0, rearrange, x equals negative 2. So when x equals negative 2, the whole equation goes to 0. Or, we'll do the other one, x minus 2 equals 0, x equals positive 2. So in conclusion, solve, this equation will be true if x equals negative 2 or if x equals positive 2. Next up, solve by factoring. In this case, we notice right away there's no number in front of the a, or there's no a value in front of the x squared. So I probably am not going to be using, or I'm not going to be using greatest common factoring here. So instead, we're going to take a look at our factoring process for simple trinomials. So we want two numbers that multiply to 24, but add up to negative 11. So we can list factors for 24, 1, 24, 2, 12, 3, and 8. 4, and 6. And at first glance, none of those add up to equal negative 11. However, remember that we can also multiply negative values together to get positive numbers. So I could also have negative factors. And hopefully we notice that negative 3 plus negative 8 is in fact negative 11, which is our b value. So I'm going to use factoring by decomposition. There are other ways of doing this, but this is the way that makes the most sense to me. So we're going to rewrite our equation, x squared. Instead of 11x, we're going to represent it as negative 3x and negative 8x. So negative 3x, negative 8x plus 24 equals 0. So just to be clear, this, the negative 11x, has been replaced with minus 3x minus 8x. So we've decomposed that central term into two different terms. Now I'm going to factor by grouping, so the first two terms and the second two. So x is factored out, we're left with x minus 3. Factor out a negative 8, we're left with x minus 3. And now I look at each of these terms, so one term, two terms, and they have a common factor within them, and that's x minus 3. So we're going to factor out the x minus 3. We're going to be left with x minus 8, and the whole thing is equal to 0. Now, once again, we're going to set each factor equal to 0. I'm running out of room, so I'm going to not show all my work, but you should when you're showing your work for an assessment. X equals 3 or x equals 8. In either case, if I plug in x equals 3 or x equals 8 into my equation, I will get that result of 0. Question 3 once again asks us to solve, but it's not equal to 0 this time. I have two equations set equal to each other. I'm not going to demonstrate this, but you could graph each of these separately in Desmos, y equals this, and see where they intersect, or we can solve it algebraically, which is what I'm going to show here. I'm going to start by expanding and simplifying and trying to get each side of the equation in simplest terms, and then we're going to move terms over so that the whole equation is set equal to 0. So I'm going to start by multiplying and distributing 3x through the first set of brackets. So we're going to have 3x squared plus 12x equals 2x plus 24. I want to get rid of the terms on the right side of the equation, so I'm going to subtract them from both sides of the equation. Remember, whatever we do to one side of an equation, we do to another. So I'm going to be left with 3x squared plus 12x minus 2x is 10x minus 24 equals 0. All right, and this one's going to get a little trickier in that it's not really factorable. So first of all, can I do greatest common factor? Well, I have 3 and a negative 24. Those are divisible by 3, so that's a common factor. But I can't do that with 10, so that's not going to work. It's not a simple trinomial, so we can't use our simple trinomial methods. And we can't use our complex trinomial factoring methods either. It's not going to work. So basically, once again, there's different ways of doing this. It's not the main point of the video, but just to show briefly, a times c is negative 72. And I want to consider, are there any factors of negative 72 that are going to sum up to equal 10? And the answer is no, but let's see why for a second. So 1 and 72, it doesn't matter which one's positive or negative. I'm not going to worry about that just for the moment. 2 and 36, 4, 3 and 24. And I can't do all of this in my head, so I'm literally just dividing 72 by each number and seeing if the result is a whole number, an integer. 6 and 12, 7, 8, and 8 times 9. So once again, not worrying about the plus and minuses for now. Do any of these add or subtract together to equal 10? The answer is no, none of them are going to work. So that doesn't mean that it's not factorable, but it means it won't be an integer, it'll be some nasty number. So like we could graph it in Desmos once again and find the roots, but that's not the method we want to use here. I want us to be able to do this algebraically. So if it's not factorable, we're going to have to use our friend the quadratic formula. So let's do that off to the side here. X equals negative b plus or minus square root b squared minus 4ac over 2a. X equals negative, and we're using our a, b, and c value from here, negative 10 plus or minus square root 10 squared minus 4 times 3 times negative 24 over 2a. And you don't need to give exact values when you're doing this, not in this course. You can give a decimal answer, that's fine. And once again, for the sake of space and time, I'm not going to work through the whole thing. Just be careful when you're doing the algebra. I recommend doing the discriminant, the part under the square root first, and then applying the rest. But with my calculator, I can quickly tell you that the values are going to be approximately 1.62, or x is equal to negative 4.95. There are ways to do getting an exact value with a square root. Don't worry about that for this course, but if that is what you're used to and you want to work that way, that's fine. Two more questions, once again, solved by factoring. Let's start by seeing if we can do greatest common factoring. Nope. 4 divides into 4, and so does 2, but that doesn't work for the negative 25. So instead, we're going to look for some special patterns. Hopefully, you'll notice that this is a difference of squares problem again. So I can actually express this as 2x plus 5 and 2x minus 5. If you're ever not sure about your factors, you can always go back and double check by re-expanding. So using our double distributive property, or you may have seen the term FOIL as well to remember this. 2x times x, 4x squared. 2x times negative 5x, negative 10x. 5 times 2x, positive 10x, so those middle terms are going to cancel out, minus 25, which is what we originally started with. So that's just confirmation that we did it correctly. Now we need to set this equal to 0. And then we're going to set each factor equal to 0. So 2x plus 5 equals 0. 2x equals negative 5. X equals negative 5 over 2. Or, alternatively, we can set the other factor equal to 0. 2x minus 5 equals 0. 2x equals 5. X equals 5 over 2. So we've solved this equation by determining that it's true if x equals 5 over 2 or negative 5 over 2. And finally, a word problem. Let's take a look. And anytime we have something that involves like a word problem, a situation, I do recommend making a diagram. I'll require it for trigonometry, for triangles and stuff. For situations like this, not strictly necessary, but I recommend it. So let's take a look. A rectangular board has an area of 54 meters. Its length is x plus 6, and its width is x minus 3. Find the possible values of x. So I'm going to sketch my rectangular board. Doesn't have to be to scale, which we don't know the numbers yet anyway. Length is x plus 6. Width is x minus 3. And we're going to need to know the area of a rectangle here, which presumably we do. Area of a rectangle is length times width. So we know the length is x plus 6. We know the width is x minus 3. And we're told that the area is 54 meters squared, so we already know that value as well. So basically, now we have a quadratic equation we need to solve. And we need to deal with that 54 somehow. So we're just going to multiply everything together, set it equal to 0, and go from there. I'm going to leave the 54 for a moment. We're going to have x squared plus 3x minus 18. We're going to have 0 equals x squared plus 3x. And negative 18 minus 54, because we're subtracting from both sides, gives us negative 72. And we just found the factors of 72 a minute ago, so we can actually reuse that here. So we're factoring a simple trinomial. We want numbers that multiply to this and add to this. So let's take a look back at those factors. I'll actually copy them down here, and we'll see if any of them work. Remembering that one of the factors needs to be negative because it's a negative 72. So do any of these add to equal 3? Once again, sadly, no. If they did, we could do just a simple trinomial factoring. Instead, we're going to use our quadratic formula again. I'm not going to show you just because I want to keep the video not getting any longer than it is, and I don't have a lot of room. But we're going to find out that our x values are 7.1 or negative 10.1. Mathematically, both of these answers are fine. If we were to plot this on a graph, we would have roots at 7.1 and negative 10.1. But we're dealing with a real-world situation here. The width of our board or the length of our board cannot be 0, or it cannot be a negative number. If I were to plug this in, if we plugged in negative 10.1 to here, so negative 10 plus 6 is negative 4. I can't have a length of negative 4. If we were to plug it in here, negative 10 minus 3, we're going to have a width of about negative 13. Not possible. However, let's see with the 7. If I plug in my 7, 7 plus 6 is about 13. 7 minus 3 is about 4, so that's going to be the appropriate number here. So our x value has to be 7.1, and the question didn't ask this, but often we'll have similar questions that do ask you to give the actual length or give the actual width. So let's see, our length is x plus 6, and we said x is 7.1, so 7.1 plus 6, 13.1 meters, and our width, which we saw was x minus 3, so 7.1 minus 3 is going to be about 4.1 meters. And we can verify by plugging that into our original equation. We said area is length times width. We said length times width is 54, so let's check and make sure we did it right. I'm just doing this math live with you guys right now, so I don't actually know, but it should be fine. And 13.1 times 4.1 is 53.71. It's slightly off because we rounded a little bit, but it's close enough. Hopefully that was helpful. If you do have more questions, just let me know.